This video is to go over homework packet 7C. Let's look at the first problem, which is problem number 9 on the first page, which is lesson 7.12. It says for AB and P equals A plus B, draw a picture of OA, B, and P. Show that OA equals BP and OB equals AB. So where's A? A is 3, 4. B is 5, 12. And O is at the origin, and P is where? P equals A plus B, so A is 3, 4, B is 5, 12. Add them, you get P, which is 3 plus 5, and a 4 plus negative 12, sorry. So that's 8, so go 4, 8, and negative 8. Somewhere here. So we call this P. And we have to show that OA is equal to OP. So you can definitely use distance formula, or you can just simply use a Pythagorean theorem, right? This is the right triangle, right? So you can use Pythagorean theorem to see if the length OA and length BP is equal. Moving on to lesson 7.13, problem number 5, which is on page 4. Use the points A, negative 1, 3, B, 2, 6. Oh, it's not here. It's negative 1, 3 is here. Sorry. Find the heads and tail of the vector that is equivalent to vector AB. So vector AB, when you say vector AB, A is the head, B is the tail. In other words, A is the starting points, B is the end points. And you put some arrow, right? And you want to draw equivalent vector that has its head on the line with each given equation. So we gotta look at, well, first of all, what's line AB? Line AB goes this way, right? You see line AB now? Right, this is line AB. Now you're looking at y equals 2, which is this one. Do you understand why this line is called y equals 2? Simply because if you take any points on this line, y coordinate is always 2. For example, what's the coordinate of this point? It's 9, 2. What's the coordinate of this point? It's negative 13, 2. Right? You see the y coordinate is always 2. That's why we say this segment is y equals 2. Now, looking at the head right there, looking at the intersection point right there, that's not A, right? You got to draw vector that is equivalent to vector AB. Equivalent vector means that you're looking at the vector, the arrow looking at the same direction of AB. So starting from here, it's got to look this way, right? And then it should have the same exact length from here to here, right? Where should be the endpoint? That's the question 7.13. Finally, we will have 7.14, problem number 6. Says find the vector equation of a line through A, 2, 4, and perpendicular to segment the vector OA. So let's plot 2, 4 first. That's A. Here's O. Here's the vector OA. You want to draw a vector equation that is going through A, which is 2, 4. Well, also it has to be perpendicular to this line, right? So that means that slope has to multiply to negative 1. So do you remember the theorem? If you have slope of one line and if you multiply slope of the other, that has to come out negative 1 if it's perpendicular. So let's look at this. what is the slope of this, right? Rise over run, you get whatever, rise over run, right? So it's 2 over 4, which is 1.5, times another slope has to be -1. What is that slope right there, right? So starting from here, you use slope to figure out which way you're going. Well, it should be this way, right? It should be somewhere on this line. Now let's think about the vector equation. Vector equation is x equals a plus t times b minus a, right? What's a here? A is 2, 4, right? So it's 2, 4, placing a with that. And then you're going to have to find a new point on this line, for example, somewhere on this line, which could be whatever, a, b. Well, it has to be a certain number, right? Now you do, so let's call this b, right? So subtract this minus this. So whatever this is, subtract a from it. Whatever you get here, you should plug in here. And that's going to give you the vector equation of a line through point A and perpendicular to that vector. Good luck.